I designed this clock movement using planetary gears, the same configuration that Henry Ford used in his famous Model T transmission. A planetary gear setup consists of 3 components: the sun gear, a plate holding the planet gears, and the ring gear. Any one of the 3 components may be used as the input. Either of the remaining 2 will be the output, provided the rotation of the other one is prevented. 2 gear setups are required, one with a 36-tooth ring gear and one with a 48-tooth ring gear. Both sun gears will have 12 teeth, and the sun gear will always be the input. If the ring gear is locked, the speed of the carrier plate rotation is calculated as shown. If the carrier plate is locked, the ring gear will counter-rotate at a different speed. The second hand on a clock makes 1 complete revolution each minute. There are 720 minutes in a 12-hour clock cycle, so I'll have to achieve a 1 to 720 gear reduction. Here I'm fluxing the main shaft. A sun gear will be soft soldered to one end of this shaft. Eventually, the second hand will be clamped to the other end. 2 custom high-speed steel cutters are required, one to cut the integral sun gears, one to cut the ring gears. I've mounted my Dremel on the quill to control the grind, which is done using an abrasive cutoff disc. The cutter is clamped in the tool holder from my home-built slotting attachment. To make things more interesting, the teeth on the ring gears will be cut in a blind hole. This is a home-built slotting attachment I built for my mill, specifically for this job. Here are all the components for the clock movement itself. The second hand, mounted on the main drive shaft, will rotate at 60 revolutions per hour. The first bank of planetaries reduces the speed to 20 revolutions per hour, counterclockwise. The second bank reduces it to 5 revolutions per hour, clockwise. The third bank rotates at 1 revolution per hour, clockwise, and includes a simple clutch for adjusting the indicated time. The fourth bank rotates at 1 revolution every 4 hours. And the final bank rotates at 1 revolution every 12 hours. Okay, so let's bolt some hands on this puppy and take her for a test drive. Well, that seems to have worked out pretty good. I plan to use a pendulum as a propulsion device. so some serious experimenting is called for. My goal is to have the pendulum cycle once each second. My pendulum shaft runs on tiny sealed ball bearings. I'll build a crank on one end with a pawl on it, much like the inside of a ratchet, so it can claw the movement ahead 6 degrees for each stroke of the pendulum. With an unconventional clock movement like that, I decided that it would be righteous to build an unconventional cabinetry for the clock as well. Well, that was an interesting project. The pendulum, of course, peters out after about 4 or 5 minutes. I guess I'm going to need some electronics or something to keep it going. But that's a story for another day.